Can you see that?
Yep.
Yeah.
Presentation up. Cool. So yeah, I'm do a quick presentation on a steam condenser I made recently. I've got a problem in the space that I brew in that it's quite small. It's about 3 meters by 3 meters, and I can't send the steam out of the door or the window because I've got neighbours on either side who weren't too happy about the steam before. And the only option I had was to drill through a chimney breast, which was kind of 4 or 5 bricks thick. And I didn't fancy doing.
Speak up a bit, Tom.
Sorry, I'll get closer.
Yeah.
Is that
I'm
better?
not, I was struggling to hear. I don't know if anybody else
Me
was.
too. Yeah.
Oh, okay. Come on, Tom.
I will shout louder. Is that better?
Yeah, perfect.
Thank you.
Cool. You just get to see my face really close now. So yeah, the problem I was having is my brewing space is about 3 meters by 3 meters, and I can't send the steam out of the door or the window because I've got neighbours either side who are complaining. I could have drilled through a chimney breast, and that would have been 3 or 4 bricks thick, and I didn't fancy doing that. So I was looking for an alternative. So I found stuff online about building a steam condenser, which is basically a chamber that you bolt onto the side of your boiler, and you spray cold water into it, and it condenses the steam, which causes a vacuum because the volume contracts, and it pulls more steam in, so it's a cycle. And then you dump the resulting hot water down the sink. Most of the information I found was on this thread, which is like an 80-page thread on the Homebrew Forum, with loads of people experimenting, kind of using different techniques, different tools. Yeah, so basically all the information you need, you can find here. The general idea is you have a T-piece or a T-shaped chamber that's off the side of your kettle, and you feed groundwater into the top, and you spray it using a nozzle, and you have a drain at the bottom that takes the wastewater out. The essential parts you need are a bulkhead fitting on the side of your kettle that allows you to attach something to it. You can also attach it to the top with maybe a 90-degree bend. I'll talk about that later. You need a spray nozzle to spray the water and some hoses to get rid of the wastewater. So this is my one. There's a tap at the top with the cold water feed. It's a tri-clamp fitting T-piece with the nozzle inside. And then I've got a 90-degree elbow at the bottom with a hose attached to take the wastewater away. That's it, a bit closer. You position the nozzle inside so it's in the steam path, but positioned so that the spray doesn't obviously leak water back into the kettle. I had to kind of adjust the height of the nozzle using a few plumbing pieces to get the height right, but it wasn't hard to do that. The only difficulty I had here is that cross piece there, the tri-clamp fitting is a solid stainless steel cap that I had to buy and then drill through. And that was the only kind of bit of DIY that I had to do. And you can avoid that, but that kind of took probably an hour of careful drilling to get through that. If you get your pieces, or if you choose the right pieces, you can avoid all of that headache. The other challenging bit is getting the right size nozzle. Again, I'll talk about that in a bit. But this is the nozzle that I had, and it produces a solid cone of cold water at the correct flow rate. I said the hardest bit of buying and putting this together was getting the nozzle right. So a lot of the information on the thread was about getting the flow right. So you need a certain amount of cold water at the right temperature to cool the steam. And for a 23, 25 litre boiler, the general advice was to get a 9 US gallon an hour, which is about half a litre a minute nozzle. For my one, I've got a slightly bigger boiler, so I've got a 100 litre boiler, and I chose a nozzle that does between 0.6 and 0.9 litres a minute, depending on the water pressure. So I measured my mains cold water pressure to figure out how many bar I had, and then figured out roughly kind of how much, what size nozzle I would need to give me slightly more than 9 US gallons an hour. That flow rate roughly equates to about 35 litres in an hour for a 65 litre boil, which kind of seems a bit wasteful considering it's just going straight down the drain. Some people collect it in buckets because it comes out kind of 60, 70 degrees once it's condensed the steam. And a lot of people use that then to clean kind of the mash tun afterwards. So if you can collect it in a bucket, you're actually reusing the heat that's lost from your boiler. And it can become very efficient. In comparison, a standard 8-minute shower is going to lose 62 litres of hot water. So in the long run, it's not that bad. The other thing I found is the nozzles don't react that well to loss of pressure. So you can't control the flow rate easily with a tap. You either get full flow with a nice cone spray, or you get nothing. You get kind of droplets coming out, which are not going to do what you want. So one of the most important things to do is to size the nozzle correctly to the kettle you have. And in the UK, it turned out that was the hardest thing that I came across. You can get lots of nozzles on eBay that are used for things like fire suppression systems, but their job is to get as much water out as possible, and you don't want that because you're wasting water then. And I did find... Hello?
Yeah, quick check there. So the nozzle's just a nozzle, it's not adjustable?
No.
Like a spray gun thing for spraying cars or pharmaceuticals has like a hole with a pin in the middle, and then you can move the pin up and down to adjust that. So these are just, and is that because they're a lot cheaper, or like?
I was following the instructions on that Homebrew thread, and in America you can buy for like £3 a stainless steel nozzle that's the right size. And I didn't want to experiment too much, so I tried to track down something that was equivalent to that. I think if you experimented a bit, you might be able to find something that is adjustable that works well. I found an industrial process nozzle. The nozzle itself was £7, but the company had a minimum order price of something like £25 plus delivery. So the nozzle was about 32 quid. If you get a group of people together, obviously you're going to get that a lot cheaper.
That's quite a different £3, isn't it?
Yeah. You could order it from the States, perhaps. It's McMaster, I think, is the company. And they're easy to get hold of. I spent a long time shopping around, and a lot of companies that make nozzles don't want to sell you one nozzle. It's not worth their time. So this is the one area where you might want to experiment. But the nozzle I got works really nicely, and it produces a very nice, very fine cone using my water pressure at the flow rate that I need it to. Cool. As I said, you can mount it on the side like I did. Obviously, if you do that, you're going to get a reduction in kettle volume. I lost about, I guess, 5 litres in mine just from the bulkheads fitting on the side. Some people have them attached with a 90-degree elbow off the lid of their kettle. but you've got a balance issue then. You've got something very heavy hanging off the side of the kettle lid. You've got steam trying to lift that kettle lid. So you're going to want something to clip the lid down if you use a top exiting mount. Things I learned using the condenser. First of all, it worked way better than I was expecting. I'll show you a video later. I had a full boil of 60 litres where the kettle was actually lifting and rocking itself. And there was no steam escaping at all. You need to create the initial vacuum. So if you don't do anything, the easiest path for the steam is to lift the lid and it will come out the sides. So you need to hold the lid down for 10 or 15 seconds to create the cycle of the condensing. Once you have that, then there's a severe vacuum holding the lid down. The other thing is you've got a lid on your kettle now, so you're going to use a lot less energy. I have to reduce my element, the power going to my element, by 50%. So before I was getting a good rolling boil at 100%. If I do that now, then it goes crazy. I have to really kind of drop the power to the element right down, which may be a blocker for some people. You know, that's quite hard to do with a powerful electric element. You need something like a pulse width controller that will drop that power down. Or if you're using gas, you can obviously turn the gas down, or you can put a smaller element in your kettle. The other thing is that you get a lot less boil off. So in the experiments I was doing, I've got a 100 litre kettle, which is about 55 centimetres across. And in an hour boil, I was only getting about 2 litres of boil off. So you need to adjust your recipes to cope with the fact that you're going to lose a lot less liquid in the boil. The other nice thing is, obviously, if you get a boil over, it doesn't come out of the kettle; it just goes down the drain. So it's a lot cleaner. It's a lot nicer to use. You just need to be a bit careful. You need to keep an eye on the boil. You don't really know what's going on because you've got a lid on. The steam's being kind of drawn off cleanly. Everything's quite quiet. It's only when you open the lid you actually figure out what's going on. And I almost burnt myself quite badly when I've done that. You've got this vacuum in there that's pulling all the steam away. If you open and break that vacuum, all of that steam is going to start to kind of come out of the boiler. So earlier it said that steam is like 1,500 times the volume of the water. If you break that vacuum, all of that steam comes out, and it's like it's quite dangerous. So you need to be really careful when you take the lid off. And the other thing is you need to keep your wastewater tube clear. If the hose blocks that's draining that water, again, you're going to break the vacuum, and the lid will come off, and you'll get a big steam, not explosion, but you'll get a big volume of steam coming out.
You lock the lid on, Tom, just for safety.
Yeah, I'd probably recommend that, to be honest. Once it's going, you say the lid is quite firmly sucked down. But just to remind yourself what's going on, because it is easy to forget that you do have this boil going on in there. You'll see in the video in a minute. But a clip, even if it's not actually doing anything, will remind you what's going on. So yeah, I'd recommend that. As for the cost, it's not cheap, it's not expensive. So if you can boil outside, it's free. If you've got a window and a door, a bit of kind of dry cleaner hose or something like that, it's pounds, it's nothing. However, it's not as expensive as something like an extractor hood. you don't need to kind of do the electrics. You don't need to drill holes. So it's reasonably expensive. It's not as expensive as it could be. I did a price breakdown last night, and I reckon you can get most of the parts for about 60, 70 quid from AliExpress. I made some mistakes when I built mine. I used a mixture of 1.5 and 2-inch tri-clamp fittings. In the UK, you can get the 1.5 stuff everywhere for not very much money. The 2-inch stuff is very hard to get hold of and is expensive. So I'd stick to kind of 1.5-inch tri-clamp. If you're careful, you can completely eradicate any form of DIY. So no drilling, it's just kind of screwing things together. The only problem is you've got obviously the long lead time. It's kind of, I guess, 2 months at the longest to get stuff from China. This is the easiest part I found. So this is an oxygen, an inline oxygenator T-piece, but it's going to give you all the bits you need. This was $30 delivered. So take the oxygen stone off the end and attach the nozzle to the cap there at the bottom. You've got one of the tri-clamps and the seals you need, and that's going to give you kind of, I'd say, 60–70% of all the parts you need to do it. Obviously you need the bulkhead fitting and a nozzle and a few more tri-clamp pieces, but I reckon 50–60 quid delivered would do it. There are a few people who make them pre-made. So there's a German chap for 126 euros. Looking at the parts he has there, I don't think that's as good as what you could put together yourself using AliExpress. But if you want something delivered all in one without having to do the shopping, then that's an option. There's a big one in the States that uses a giant 3-inch chamber. I think this works really well for large kettles. But again, it's $145 plus delivery, and I think, to be honest, if you spent an afternoon on AliExpress, you could probably put something together yourself for half that. So things I don't know. I think I got lucky. So you can get nozzles with different cone profiles. So you can get hollow cones or solid cones. I don't know how that affects the condensing. The chamber diameter, size and shape, I don't know how that affects the efficiency of the condenser. I chose an offset T-piece like this, so the majority of the spray is in the longer section on the left. My reasoning behind that was that there's more contact time between the cold water and the steam. Again, pure guesswork. I just know the combination that I have works well, and that's that shaped T-piece. I don't know whether the bulkhead size makes a difference. I have a 1.5-inch bulkhead fitting, and that seems to work for 100-litre kettle very well. I also don't know whether how well it works to boil off, DMS and the various things that you want to boil off in a boil. Everyone on that giant 80-page thread was saying that they haven't had any problems. And I did my first beer at the weekend using this, and last weekend, and I can't taste any off flavors whatsoever. So
in a vacuum, you could argue it's better, right, Tom?
That's what I understand. Yeah.
Yeah, that's what I would think. That basically it pulls out all the components out from the boil. So yeah, I think it's even better than just a normal boil. Like
I could pull off your hop aromatics as well. So it's probably getting the right balance, I'd imagine.
Yeah, you do get one thing it doesn't get rid of is the aroma. So the liquid that comes out, the wastewater, has a very strong smell. It's all of the things that you have during a boil, but very concentrated. So yeah, if you want to get rid of aroma, this is not going to do it. If you want to get rid of the steam, this is a good option. Okay, I'm going to show a video. I don't know how well this is going to work. I'll post it on the Slack channel as well. This is a 60-litre boil with just water. It's basically 100% of the element boiling. You'll hear the kettle rattling around because the water's being thrown around so violently that it's actually making the kettle rock. And you'll see kind of the flow of the water that I'm talking about.
Tom, that didn't really work, but that sounded as good as the illegal raves around here, actually.
I'll post the link. I didn't think that bit would work. It's up on YouTube. I'll put a link on the forum so you can watch it. Cool. So that's the end. Has anyone got any questions?
Wow, well done.
Have you basically made a pressure cooker, which is going to be, is it boiling at lower temperature? And is therefore going to have, I don't know, whatever that means?
It's the opposite of a pressure cooker because there's a vacuum in the lid.
Yeah, okay.
The steam's condensing, so it's actually, it's the opposite.
So it's going to higher
The
temperature.
efficiency comes from the fact you've got a lid on. From what I found, it makes a massive difference. You're not losing as much heat from the steam. You're not losing as much heat from the from the kettle itself.
So if it's boiling at a higher temperature, it's going to affect your hop utilization then, isn't it? It's the opposite to the issue I've got at altitude in Chamonix.
Boil at a lower pressure, lower temperature because the vacuum.
So it's the same as me. Same as me.
It's the same as a pressure cooker.
Yeah. Right? Am I right?
Yeah, that makes sense. Yeah. I've not noticed a massive difference, although I've only ever brewed at altitude, really, and I guess you just get your recipes dialed in, don't you?
Out of all the things I've kind of put together over the last few years, it's the one thing that genuinely impressed me how well it worked. I wasn't expecting much, to be honest. I thought I was going to put the lid on and the lid was just going to lift and steam was going to go everywhere, but it didn't. And once that vacuum's going, the lid's hard to pull off. You have to give it a bit of a yank to do it. And I don't have kind of steam dripping off the walls. I don't know how well it's going to work in the winter, because I tried it the first time and it was about kind of 18 degrees outside. Obviously, you're probably going to get more steam in the winter, maybe. I don't know how that's going to affect things, but I'm very pleased with the way it works.
I wonder if the temperature of the water that you are putting into it will have any effect as well.
I was wondering that. Yes, I was wondering that whether the input, the groundwater, so to speak, temperature.
When you first turn the tap on, there's no vacuum, so the water comes out at ground temperature. When you hold the lid down and get the cycle going, it raises very rapidly, and I was measuring it at about 60 to 70 degrees when it was coming up. So I guess as long as it's not boiling, you've still got that 30 degrees to play with. So even if the groundwater temperature increases a lot, it's not, there's still enough capacity in the water to draw the heat off the steam.
That sounds pretty efficient then.
I think so, yeah.
Yeah, that sounds pretty efficient.
My guess would be that the groundwater temperature won't have that much of an effect because it's actually you're vaporising through the spray, and it's actually that surface area that's making the difference. I'd guess. Educated guess, but I guess.
So perhaps the nozzle shape and the chamber size is pretty critical to the setup.
I get the feeling it might be, but I don't know what the relationship is. And if you read through that thread, you can see lots of different implementations from various people, and they all say that they generally work. There's no one on there who says I've put something together and it just doesn't work.
Yeah.
So I think even if if you get it slightly wrong, you're still going to be fine. But yeah, that's the guesswork, I guess.
Tom, don't know if you can see behind me there, but my setup is I've got an ex-cooker hood there, which has got an extractor fan in it. Currently goes out through this elephant's trunk out of that window there. If I didn't have that window there, if I just drop that into a bucket of water, would that have the same effect?
No, because the pressure of the steam, maybe if you clip the lid down, but I think what you'd have is just huge steam bubbles coming out of the water, because the water.
So I've got an extractor fan in the cooker hood, which draws the steam up then out of the vent at the top. Yeah,
but you don't want to block the exit. You don't want to put any resistance on the exit of the steam. As soon as if you put the whole tube in a bucket of water, the steam wouldn't have enough pressure to bubble through the water.
Probably rip off that sleeve, because what you really need to do is basically cool down the steam. The vacuum. Otherwise, the steam will completely fill the sleeve and might blow it off. Yeah,
they're quite weak, aren't they? Those fans. I think they're quite sensitive. Even if you get the run too long on them, then they stop. They stop working. Any pressure, any back pressure on them is bad.
Yeah. And you're creating an awful lot of steam. I mean, the volumes of steam that you're creating are huge in a boil. I mean, because water creates such a large volume.
It's 5,000 to 6,000 litres of steam during a boil. That you need.
How many?
You said, Tom,
6,000 litres.
Right.
You said it was 1,500 times. The steam is 1,500 times more than the same volume of water. So when you condense it, it's 1,500 times less. So that's the vacuum you're pulling.
Yep. And it's that cycle that's important. I don't know if you, on one of the pictures I had a steel pipe coming off the wastewater hose. That was so I didn't get a U in the hose. If you get a U bend in the wastewater hose, the steam doesn't have enough pressure to push the water out, so the whole thing fails. So you need a clear run from the outlet of the kettle all the way down to the sink, basically. If any of that gets blocked, the whole thing stops.
And do you do mid-boil hopping, which involves taking the lid off, which is, as you said, can be a dangerous procedure?
Yeah, that's how I found that it hurts.
Okay.
I burnt my belly, basically.
Ouch.
Quite badly.
Ouch.
Scalded.
Yeah. It's just you forget. It's simple. There's no steam. There's no real noise. You've just got a trickle of water. But in that kettle, you have 60 litres of boiling water. And the second you take the lid off, you release it.
So how did you get around that? Have you bought, like, what have you done? Made things that you can open that drop them in, or what are you doing?
I was basically I was opening the lid at the back. So putting my hand on the front of the lid, using the handle to lift it so that the back opened first. And it was blowing the steam up against the wall.
Right. Did I see your lid had an inch and a half tri-clamp outlet on it?
On the top, yeah.
Could you not attach a ball valve to that, which you could open and close to depressurize?
That's a very good idea. I'll do that. You could use that maybe to dry hop, to hop as well. So if you
there you go.
Hops,
Or you could bang a pressure gauge on it.
yeah, see what's going on.
Your neighbours really complain, and like, surely you should just gas them with the steam or something afterwards. You must be able to bribe them with beer, Tom. Come on.
Actually, the one who was complaining left. But on the window, I've got a window on the left-hand side, and that's the gap between the flats, and it's only maybe about 10 feet. And in the winter, that was filling up with steam. On the door side, there's another neighbour on that side. So, yeah, it's also fun. I like building stuff.
Yeah. No, it's a great project. Yeah, I'd have thought on the face of it, it looked safe, but actually you're doing a lot of, like you say, you're increasing and then reducing pressures by 1,500. That's a massive amount. So yeah, interesting.
The other thing is it's using a lot less electricity.
Yeah.
And the brew's a lot more efficient because I'm not getting the same kind of level of boil off. It's
pays for itself.
Yeah, eventually.
Yeah.
Could you use a recirculating pump, and just pump from a bucket of water background, or do you think that would just heat the water up too much?
Yeah, it really heats the water up. So from probably what's groundwater, 15, 16 degrees up to 70 degrees. And that happens in seconds. So if you hold that lid down, the groundwater temperature just goes straight up. So I don't think that would work. You'd need the constant sink of that heat.
The other thing I was thinking of to solve a similar problem was those coffee roaster mushroom hoods that you see on coffee roaster buildings. They must have a similar kind of concept where they're capturing the off gas and condensing it. I don't know what they use. Did you look at any of that kind of those as a solution for this before you built the unit you've got?
No, I literally I saw that thread and saw probably 20, 30 people saying that this worked, and I was lazy, and I just thought, okay, I'll try that.
Fair enough. Yeah, because I think I might have to do something similar. I was just wondering what other things you've looked at.
Would the coffee roaster, that would presumably capture some or all of the aroma and sort of particulate, but I can't see how it would condense steam.
Yeah, you're not generating.
That water needs to go. That energy and that water needs to go somewhere.
Yeah. And you're not generating it from a coffee bean. It's not steam, is it?
Yeah, true.
You need to cool the steam somehow and make that happen.
How are you dealing with the DMS, right? So I was always told put the lid on and take the lid off when you're boiling because it'll sort of DMS out. I don't understand how your system has solved that. Why does vacuum? How does it work? Why is it
sucking it out?
It's being sucked out and sent down the drain.
You're not leaving it there.
Yeah, it's still coming out, isn't it? Yeah.
Yeah, because it's all within the steam, so it's like all those compounds, like
it's
within
coming
the
out,
steam,
isn't it?
and basically sucking the steam out of the.
I've seen that Homebrew Talk thread, and I'm quite jealous of Tom because it's one of those projects I'd love to do, but I've got absolutely no need for it. But I still would love to do it, just to prove it can be done. But one of the guys, and it did put some cling film over the top of his kettle, and can actually see literally the moment you turn on the condenser, just pulling the steam straight out. So that's where it's going.
Yeah. Yes, coming out.
And I think DMS wise, you don't need actually all that much vapor through the course of boil to boil it off. It's very volatile, so only takes a short while to basically boil it all off. So even if you left the lid on your kettle for a while, as long as you take it off for 15-20 minutes, it'll all be gone.
Okay.
I read it's kind of more volatile than the steam that you're extracting. So
Yeah,
it's one
yeah.
of the first things that's going to go down the tube anyway.
Do you think your boil temperature might be a little bit lower? I can't remember if you said that earlier, but
the power
should be. Technically, it should be because you put in a vacuum.
Yeah, it was the thermometer was saying 101, but I had to turn the temperature right down because I was getting pretty bad boil over. Again, the only way I could see that was there was brown water coming out of the condenser drain. It was just sucking all the foam down the drain. But yeah, once I got the temperature control right, to be honest, the temperature control might be the biggest blocker for most people. Unless you've got a way of controlling the power going to your element, you've got a problem. Unless you can put a much smaller element in, you are going to get massive boil over with the lid on.
I'd be interested to see what you do end up boiling at. I reckon I'm somewhere between 96 and 97. My boil temperature.
EMS boils at less than 40, by the way.
And pops and stuff, or
so in theory, it should be longer.
At sea level.
The boil happened.
A lot of large breweries do this. I mean, because it saves them power, doesn't it?
Yeah.
Well, yeah, I think I remember seeing there was someone with an American brewery set up, and I don't know whether it was made by Spike or something, but he had a condenser on it was a 1-barrel system, I think it was, and he was running a steam condenser on a setup I think he bought, but quite a small setup, pilot sort of size. So I imagine that it must be used in commercial breweries. I mean, it would make sense in a way because you're reducing your energy in the boil.
Yeah, the macros definitely do it massively. It's an enormous cost thing for them otherwise, but they just use it to heat the water for the next brew.
I was going to say, you've got a lot of hot water there that
conserve that.
I'd have thought it would have been quite wasteful of energy. So it's quite interesting that it isn't, Tom. And often that happens, right? You think one thing and it's the opposite. So that's quite interesting.
Well, you think about like the energy and phase changes and with water anyway, but with any substance between any element between sort of gas and liquid and solid, that it's the phase change that you end up using so much of the energy to like melting ice, and it's the same thing with condensing steam, I guess. It's takes a lot I guess it also takes a lot to warm up the water from that level, but yeah.
Especially if you could harvest that hot water into your hot water tank or whatever. I mean, it sounded like, what were you, half a litre a minute, 60-minute boil, 90-minute boil, 30, 50 litres of water. It wasn't a vast amount. Probably use that in cooling, right? So if you could capture that somewhere, you'd be...
I guess the steam is like representative of excess energy that you need to boil. So if you can find a way of properly modulating the heat or the energy that you're putting into the system down. And that's one thing I was going to ask actually the group is, what does anyone have a proper power controller for that sort of thing for their elements? When I have a PID, and basically what that does is it turns on the heat, turns the element on and off very, very quickly. So if it's on 60% of the power, then its shortest phase is 2 seconds, and it will turn on the power for, if it's 50%, it will turn on the element for 1 second and then turn it off again for 1 second. But are there any better controllers than that you can go?
I think the one that I have, it doesn't do it by turning it on and off. It reduces the power output to the element.
Right.
But I can't remember how it does it. It was somebody else who made it.
Potentiometer, or
yeah.
I think I've got one too, Mark, as well. Just a cruder. They're cruder than PIDs, and I think a potentiometer or whatever. They're on eBay there.
Something else. It involves with it there's a solid state relay stuck inside it somewhere.
Yeah, so it's turning something on and off anyway, but
yeah, but it's I'm pretty sure that it's. Well, do you know? I'll need to check on that. I didn't think it was turning it on and off rapidly, but I thought it was actually delivering less power to the elements. I'm going to check that one out.
I mean, it's a common way of doing things these days. I mean, the dimmers on LEDs work the same way, because you can't dim an LED, so you just turn it off for a split second and turn it back on. And if you do it fast enough, your eyes think it's gone dim. I think they seem to be PIDs, a sort of common way of controlling power now. I mean, if you buy little voltage controllers these days for, say, a fan or whatever, and you can get these little voltage controllers. They work the same way. Pulse width modulation, I think.
Yeah, I mean that's what it is. So I just wondered if the potentiometers or something like that work better, or whether a PID that can do that is with an SSR on it is fine.
Well, I think they're more reactive, aren't they? PIDs. They're going to respond to stuff that a potentiometer won't. It's sort of just a variable resistor, really, isn't it?
Yeah. Well, to explain the PID that I've got, I can run it in PID mode, or I can run it in a hysteresis mode, which is more like your sort of Inkbird or STC kind of controller, where it turns on at one temperature and goes off at another.
Yeah.
Or I can put it in manual mode and actually set the power from 0 to 100, and it then turns the element on and off within a particular time phase, and the shortest you can set is 2 seconds.
Right.
Yeah, I don't know whether that's a fine way of working or not. If I wanted to do, I run. Sorry, go on, Tom.
The one I have is there's Orbit Instruments.
Yeah.
And they slice the sine wave of the AC signal. So rather than turning off once or twice a second, they turn off fractions of 60th of a second. So UK AC is running at 60 seconds. So what they'll do is they'll say, okay, I'm going to, if you want 50%, they'll turn on for the first rising sine wave, and then they'll turn off again. So it's 120 times a second to regulate the power.
Right.
Problem I've had with that is it makes the lights in the house flicker on and off. So I've had to turn that mode off, and I've had to go back to the mode that you're talking about, which is set a time period and say, okay, I'm going to be on for 2 seconds, off for 2 seconds.
I can never remember the difference between like phase angle controllers and burst fire rectifiers and that sort of thing.
It makes your lights flash.
Yeah, yeah.
Cool. Anyway, that's the end.
Great, Tom. Thank you.
Good. Really good.
Put a link to the video on the chat, the Zoom chat. So if you want to watch a kettle shake itself apart, it's on there.
Yeah, send us a link.